All right, this is the Chapter 2 review. Now, this is not meant to be totally covering everything, so this gives you a rough idea. You'll need to make sure you go study your book and study your study guide. Make sure you know your definitions of main terms in the chapter and be able to show your knowledge of them by doing problems with them. Remember, a conjecture is an educated guess based on known information. For example, let's say a team wins their first 3 games and you make a conjecture that they will have a winning season. Now that doesn't mean it's going to happen, but based on what you have observed, that's a guess you can make. Inductive reasoning is logic or reasoning based on examples, like a pattern. So I see this pattern. I see a triangle, a circle, a square, a triangle, and by inductive reasoning, I'm going to guess that a circle is next. You can see patterning in numbers. This is also where we talked about, like, you went to the mall and every girl you saw at the mall is wearing pink, so you assume or make a conjecture that all girls like pink. A statement is any sentence that is either true or false, but it's not both. Here's statement P. They're always known by a letter. The house is white with blue shutters. Now, that happens to be a true statement because my house is white and it has blue shutters. So the truth value, which is the next thing, the truth value of that statement is true. Now, the truth value of a statement can also be false. So statement Q, Burns has more students than Dorman. That is a false statement. It's still a statement, but the truth value of it is false. Negation has the opposite meaning of the original statement. So if I said the negation of Q, there's a twiddle and then Q. Burns does not have more students than Dorman, so I put the word not in there. It's also changed the truth value of it to true. A compound statement is 2 or more statements joined by the word and. They must both be true for the compound statement to be true. So if I have P and Q, or it can also be put this way, that's P and Q. Both P and Q have to have a truth value of true for the compound statement to be true. I could say the house is white with blue shutters and Burns has more students than Dorman. The truth value of that would be false because that statement is false. Disjunction statement is 2 or more statements joined by the word and. So this is, this is the one that's and this is the one that's or. Compound is and, disjunction is or. So P or Q, or P or Q. One of them has to be true for the statement to be true. They both don't have to be true on a disjunction statement. Truth table is a way of organizing truth values into a table form. We'll do one of those in a few minutes, but you've got to be able to do them. We also talked about if-then statements. An if-then statement has a hypothesis, follows the if part of it, and then the conclusion follows the then part. This is read P then Q. An example of this might mean if it's warm, then we will go swimming. That is the conditional statement. Okay, so that's P then Q. The converse of it is if we go swimming, then it's warm. That's Q then P. The inverse is the negation of P then the negation of Q. If it isn't warm, then we won't go swimming. The contrapositive is the negation of Q, then the negation of P. If we don't go swimming, then it isn't warm. Now, these also have truth values to them. And remember, when you're trying to figure out the truth value of an if-then statement, if the if hypothesis is true and the conclusion is false, and this is in comparison to what you've already been given as true, then the statement is false. Otherwise, it's true. Remember, this is the whole idea of it's true unless proven false, innocent unless proven guilty. All right, so here's some sample problems based on the above information. Here is a truth table. This is a P or Q and a Q or P. So we're going to have columns here. We have a P, we have a Q, we have this first parenthesis, a P or Q. We have the second parenthesis, a Q or P. And then we have the third parenthesis, which is the whole statement we're trying to find. All right, so this is where we have patterns. So my pattern here is true, true, false, false, true, false, true, false. Now remember, when there's 3 statements, you're going to have 8 possibilities down rather than 4. But if you stick to your pattern, you'll have it. Okay, so this is an OR statement. So this is true. As long as one of these is true, this statement is true. So that one's false. Same thing here. We're comparing both of those again. So true, 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 and false. Those are OR statements. But then when I switch over here, this is an AND statement. So both of these columns would have to be true for that column to be true. So that's true, that's true, that's true, and this one's false. So that gives you 3 trues and a false. Here's another example of a problem that might be using this information that you might see on the test. Write all the conditional statements for the following and give its truth value. So if the statement P is our pig is a clean animal and the statement Q is we will keep it in the house, then conditional, which is P then Q, is if our pig is a clean animal, then we will keep it in the house. And that is true because I was given that. All right. Now I can do a converse, which is a Q then P, and it says if we keep the pig in the house, it is a clean animal. And you could make an argument for this being false because you could go, well, maybe it gets sick, so you keep it in the house. So it's not necessarily a clean animal. So we're going to go ahead and put false here. Okay, hopefully these are a little bit more concrete than the pig being a clean animal, but just because you keep it in the house doesn't mean it's a clean animal. The inverse is the negation of P, then the negation of Q. So if our pig is not a clean animal, then we don't keep it in the house. And I would argue for the fact that this is true because what you've done up in the original is you've said that part of the parameters of keeping it in the house is it has to be clean. So if it's not clean, then we don't keep it in the house. But again, you could go back to this one and say, well, maybe the pig's sick, and so it gets put in the house anyway. So these, you really could argue the truth statement, the truth value either way. The contrapositive is the negation of Q, then the negation of P. So if we do or don't keep the pig in the house, then it isn't clean. Maybe not. Okay, so just because if we don't keep the pig in the house, we can't say that it isn't clean, because I might give it a bath and not have put it in the house yet. So this is false. You could come up with a counter example or a counter situation to go against this. All right, more definitions. Deductive reasoning is logic or thinking using concrete rules, laws, or theorems or postulates. We talked about two of them. Law of detachment, which says if you have this to be true, if I have a hypothesis and then a conclusion, and the hypothesis is true, then I can conclude the conclusion. The law of syllogism says if P then Q is true, and Q then R is true, then P then R is true based on law of syllogism. Here's an example that you might find from those. This says determine whether statement 3 follows statement 1 and 2 by law of detachment or law of syllogism. Perpendicular lines intersect. Okay, so this is P. You have perpendicular lines and they intersect, which is Q. And then I say lines P and M are perpendicular, so that's P. So right now I have this. I have P, then Q. I know that's true. And I know P is true. So therefore, I can conclude Q, which is M and N intersect. So this is P, then Q, then P, therefore Q, because this one's Q. So that is true based on law of detachment. So if you can assign letters to your statements, it does help you see whether that pattern is followed. The pattern has to be followed for it to be valid reasoning based on one of those two. All right, make sure you look at your study guide or through your book for postulates and theorems that are available. I put them on your study guide. I'm not going to repeat them here. Those postulates and theorems are used in algebraic proofs and geometric proofs, and some of the postulates and theorems are just used in problems besides proofs. Hopefully some of your homework will show that. This is an algebraic proof, okay, and I've already got the given and the proved down, so I'm going to go ahead and do my 2-column. Okay, this is your statements. This is your reasons. Remember, these have to be numbered. So you start out with 4x plus 9 equals 17. And the reason that you can state that is that it was given. First thing I'm going to do is I'm going to subtract the 9. Make sure you're showing this. That is by subtraction property. Then my third step, I write what I have left on both sides. That is by substitution. Now I need to divide to get rid of that 4, which is division property. And then by substitution, I have that x is equal to 2. The majority of the proofs that you're going to find on this test are going to be I shouldn't say the majority. You're going to find some algebraic proofs on this test. But you also have geometric proofs, so here's an example of a geometric proof. Notice that these do not have congruency on them, so you don't have to worry about taking them off. I've already got my given, I've got my proof, and I've got my illustration. So the first thing I want to do is I want to write my given down. The reason is given. Now at this point I would probably go up and mark this. BC is congruent to EC and CA is congruent to CD. What I'm trying to prove is that whole line segment is congruent to that whole line segment. So you can bet you're going to go in the direction of segment addition. So BA is equal to BC, that whole part, that, and then C plus CA, BC plus CA. And at the same time, I can say EC or DE, which is this whole line, is equal to EC plus CD. Okay, so the whole line is equal to each of the parts added together. So that would be, because of the postulate, that's segment addition. The whole is equal to the sum of the parts. Now if you look here, you can do some substituting. So I have the idea that BC is equal to EC. So I can turn around, and in this one I can say BA is equal to, and rather than writing BC, I write what BC is equal to. And then I can, oops, I want that as a plus, okay. So then I can substitute CD for the CA, because the CD is equal to the CA. Now my purpose behind that was to get that to match this, and that was simply by substitution. So let me say that again. What I did was I replaced the BC. If you see BC right here, I replaced it with that. And then this one I replaced with that, because BC is equal to EC and CA is equal to CD. Now those two things equal. So you can turn around and substitute for this. Okay, rather than writing EC plus CD, I'm going to write what it's equal to, which is DE. Now, you could have also done transitive property here, but I did substitution. So now I have what I was trying to prove. So all the way through, I did segment addition to show that the whole line is equal to the two parts. Then I replaced the parts on one of the line. So rather than writing BC, I wrote EC. Rather than writing CA, I wrote CD. So now EC plus CD and EC plus CD match. So these two things, because they're equal to the same, can be equal to each other. So you could have done transitive property here, or what I did was I just took this part and I substituted the DE in it by substitution. All right, your homework on this is page 115 through 120, 10 through 58 even.